This is lesson 1.3, part B of Foundations in Pre-Cal 10, starting on page 21 of your workbook. And this is a review of the exponent laws that we did in grade 9. So let's just work through this. 8 cubed times 8 squared, we can expand that to be 8 times 8 times 8 times 8 times 8, which equals, if we just look at this, we count that up and it's 8 to the 5. And the shortcut to get that is that it's 8 to the 3, because there's 3 in this group and 2 in this group. So we're just adding up the exponents. So it's 8 to the 3 plus 2, which simplifies to 8 plus 5. When we do this with a variable base, same thing. We've got a times a times a times a times a. So that simplifies to a to the 5, just looking at it, but we get it by going a to the 3 plus 2. So the product law, and this is the one that we need to remember essentially, is that when we multiply powers with the same base, we add the exponent. So this is a to the m plus n, whatever m and n are. And then the quotient law, we can, if we write it out like this, we've got 8 times 8 times 8 divided by 8 times 8. We can see that some of these 8s are going to cancel out, and we're just left with 8, just a single 8, which is 8 to the power of 1, and we can get it. The shortcut is by subtracting the exponent, so it's 3 minus 2. Same thing when we have it with letters. These A's are going to cancel out, left with 1, so we're left with a to the 1, or a to the 3 minus 2. So the quotient law is that when we divide powers with the same base, we subtract it, so it's going to be a to the m minus n. If you're writing out a page of this for yourself, I really recommend that you write out both ways of looking at this, because those are equivalent. They're just different notations for the same thing, and it's a good thing to have them both in front of you. This, of course, is only true if a is not equal to 0, because you cannot divide by 0. All right, now we have the power of a product law. So we've got two things we're multiplying together, and we're cubing it. So we've got 8 times 7 times 8 times 7 times 8 times 7. If we rearrange this and we put all the 8s together and we put all the 7s together, because of course when we multiply, the order does not matter, we've got 8 cubed times 7 cubed. And then we can do this with variables, same thing. We're going to a times b times a times b times a times b, group the a's, group the b's, and we can see that we've got a cubed and we've got b cubed. So basically what we're doing is this, at the exponent, applies to everything inside the brackets. It's kind of like a distribution thing. So a times b all to the m becomes a to the m, b to the m. And we do the power of a quotient. Well, if we have 8 over 7 cubed, we can expand that to be 8 over 7 times 8 over 7 times 8 over 7. And then we could rewrite, they didn't really show this here, but we could rewrite that when you multiply fractions, you multiply top times top and bottom times bottom. So this becomes 8 times 8 times 8 over 7 times 7 times 7, which equals 8 cubed over 7 cubed. Same thing here. This becomes a over b times a over b times a over b, which is a cubed over b cubed. So the rule in summary is that a over n all to the power of n becomes a to the n over b to the n. Now we're going to do the power of a power. So if we have 8 cubed all squared, that means that the exponent 2 is applying to the brackets, right? So that means everything inside the brackets is getting multiplied by itself that many times. So in this case, it's 2 times. So it's 8 cubed times 8 cubed. If we expand that, that becomes 8 times 8 times 8 times 8 times 8 times 8. And if we count all those 8s up, we can see that we have 8 to the 6. The shortcut is that we just multiply the exponent. So that's 8 to the 3 times 2, which is 6. We can do this with variables as well. So a cubed all squared A cubed times A cubed is A times A times A times A times A times A. So if we count that up, we can see we've got 8 to the 6, which we get from 3 times 2. Okay? And so if the rule is a to the m all to the m, sorry, a to the m all to the n becomes a to the m times n. All right. So this last column is what you kind of need to memorize or be able to figure out on the fly, whichever that is, whichever works for you. The other two columns are just so you understand where those rules come from, just by way of example. Okay. Let's look at a couple of specific examples. All right, and as always, if you want to pause and try these on your own, you're welcome to do that. I firmly believe that when you are learning these things, anything, writing out the process each time really helps you, even if that's not, when you've done it 1,000 times, you're not going to do that anymore. But when you're learning, writing out the steps really helps you to remember it. So that's what I'm going to do here. So this is 3. I'm multiplying them, so I'm going to add the exponents. So it's 3 to the 4 plus 2, which is 3 to the 6. And when I evaluate that, it's 729. So I'm just going to, all right, so my simplify is the yellow highlighter, and the evaluate is the green highlighter, okay, because it's important you know which of those is which. Yeah, so simplify means make it the simplest exponent that you can, and evaluate means tell me the actual number if you can, all right? Yeah, okay. So this is going to equal -2, that's my base. And since I'm dividing my powers, I'm going to subtract my exponents, so that's 5 minus 3. So that equals -2 to the 2 squared. And when I evaluate that, that equals 4, not -4, it's +4 because it's a negative number times a negative number. And then this one is going to be 5 to, I'm doing a power to a power, so I'm going to multiply my exponents. Oops, 3, so that equals 5 to the 6. Don't expect you to know what 5 to the 6 is, but if you are allowed to use a calculator, it's 15625. And I'm just going to do that coloring again so that, I don't know why they make that so difficult. This is, that's the simplified, and this is the evaluate. Okay? Usually you could actually write this one here. You could do that and write it as 2 squared. Either one of those is fine. I prefer actually that you just keep the base the same because that's showing what the base is, but I wouldn't mark it wrong if you wrote that as 2 squared to simplify it. Okay, use the exponent laws to simplify. Now we're being specific about using the exponent laws because we don't want you to multiply these things all out and count them out. The point of this is to be able to use the exponent laws. And if I made this a to the 712 times a to the 14, you can add those numbers. I don't want you to have to write all that many a's out and then count them up. That would be crazy. Okay, so this is a to the 4 plus 3 equals a to the 7, and I'm sorry that comes up looking like a 9. That's because of the tablet that I use. This is x to the 6 plus 1, which equals x to the 7. This one, there's two ways I can do this. I can go, this is b to the 7 plus 0 plus 4, which equals b to the 11. Just trying to change pens up here. Or I can look at this and go, anything to the 0 is 1. So I can just ignore that because if I multiply something by 1, it doesn't change anything. So this is b to the 7 plus 4, which is b to the 11. Either of those, of course, you get the same answer, so it doesn't matter which one you use. This is x to the 8 minus 4, which equals 8 to the, oops, sorry, x to the 4. Okay. This one is y to the 10 minus 2 equal y to the 8. And I want you to be able to make sure that you can also visualize what's happening there. You've got 10 y's across the top and you've got 2 on the bottom. 2 of them are going to cancel out. You're going to be left with 8 on the top. This is a to the 4 times 3 equals a to the 12. Next row, this is going to be y to the 5 times 5, which is y to the 25. When I've got a fraction, I apply the exponent to both. So this is x to the 9 over y to the 9. This is going to be c squared over 4 squared. Now, you are asked to simplify this. Simplifying, this is a little bit odd. Up here, when we're asked to simplify this, because you were asked to simplify and then evaluate, and there were no numbers in it, or no variables in it, simplify means leave it as a single exponent. And that would be better instructions, would be use the exponent laws to write as a single exponent. That would be this. And then evaluate, which would be this. When you're asked to simplify something like this with variables in it, you actually are expected to multiply out any numbers that you have, so that this would be c squared over 16. That is the answer that I would be looking for simplify that. Okay. You can't, of course, you can't simplify this one any further because you don't know what x is, so that can't get any simpler than that. But when you have a number, figure out what the number should be. All right, this is s to the 6, t to the 6. This one, the best strategy for doing this is to actually just follow the same process you've been doing. This becomes 2 to the 5 times a to the 5, and then simplify this piece, which is going to be 32a to the 5. Often when students have this, they give me 2a to the 5, which is not correct because the 2 gets multiplied by itself 5 times as well because it's in the brackets, right? Same thing for this one. I would do this as negative 3 to the power of 4 times p to the 4 q to the 4, and then simplify or evaluate this part, which is 81 p to the 4 q to the 4. Okay, and that is it for this lesson. Go and do the practice. Make sure you mark it. Don't wait to the end to mark it, and see you soon. Bye.